I will pass the word to Lindsay so she can present herself and say her speech. Thank you.
Sounds great. Thank you, Claudia. As Claudia mentioned, my name's Lindsay, and I'm with a company called Cartosa. We're an open source geospatial consulting firm that is based out of South Africa, but we have staff all over the world. And I am based just north of Washington, D.C. in the United States. So I'm up in Baltimore, Maryland. But I'm originally from the western part of the United States, specifically Colorado. And that's where I started out my career in the geospatial realm. And I actually worked for Electric and then moved on to work in a variety of different utility spaces, doing specifically GIS. And so here at Cartosa, I've continued that work on utility-centric projects, implementing open source geospatial solutions in a variety of electric, fiber, and water applications. So Cartosa partnered with BGO, and I was immediately very excited to see the product that they are deeply involved with and that they implement called Giswater. And Giswater is an open source application for water cycle management and includes network and hydraulic modeling, and it runs on the open source GIS desktop software called QGIS. So here in the States, I was very excited about this because oftentimes I feel like the utilities realm can be a little bit dominated by proprietary solutions. And so I certainly did not know that there was such a robust and advanced solution available in the open source realm, especially when it comes to utilities. So I immediately recognized the value of it. And I was really, really excited about it when I saw BGO configuring it and implementing it, and overall just very excited about it. So as such, today you're going to hear lots more about the product and how it works, and you'll get a whole bunch of detail from the BGO team. But I was just excited to advertise Giswater a little bit in the American space, just to introduce folks to options that are outside of the proprietary realm. So with that said, I will hand it back over to Claudia, and you all are in excellent hands today. You're going to be hearing from some really excellent experts, and I think you'll really enjoy today's webinar. So back to you, Claudia.
Thank you so much for your kind words, Lindsay. It is a pleasure to be on board in such a thrilling experience at the same time. So as I said, this webinar will be presented by me, Claudia Rodrigues. I'm the community manager of the Giswater Association, but also Vicente Medina, PhD at the Polytechnic University of Catalonia, and Xavier Torret, technical manager of the Giswater Association, as well as partner director of BGO. I'm from Portugal, in Madeira Island, while Xavier Torret and Vicente Medina are from Barcelona in Spain. So let's get started. The Giswater project was born on 2014 in Barcelona, in the scope of a joint venture between the Sediment Transport Investigation Group of the Polytechnic University of Catalonia and the company BGO. The evolution of the project would not be possible without the trust of water supply companies, consulting firms, users, among others. Therefore, we would like to say all of them a big thank you. Xavier, can you? Thank you. The next point I'd like to address is the mission of the Giswater project, which is to help water utilities using digital technologies to transform operations and systems, sharing knowledge. Let me try to explain you this sharing knowledge, which consists on two concepts, which are based on our vision. The first is the open innovation, which joins the collective intelligence of all the users of Giswater, who suggests different functionalities to the tool in order to keep improving it. While the second is the shared value, is based on the joint negotiation with clients, but also share expenses on the development of projects. In the next slide, we will show you some examples of this sharing knowledge. So in the first image on the left upper side, we have the code development. To develop workflow dialogues and process of code according to the decisions of a work group of the association. In the second image, where Xavier appears, is represented the webinars, workshops, and the trainings, which are a good opportunity to share knowledge. In the third image, represented by the large pipe, is the development of collaborative projects. While the research plus development is expensive, it is also mandatory nowadays. A good environment to outsource it is joining forces like we did for the stormwater management model IBER project, where 9 companies propelled it. And last but not least, we have the B2B meetings. It is very easy to make advantage of B2B if both companies use the same technology, which is also open. Share code script, share best practices, and so on. Now, let's have a look at how Giswater can be used. In addition to being a very interesting tool to digitalize your network assets, as it is GIS and has hydraulic models prepared to simulate as a digital clone, it has other advantages such as being open source. It can work with big data. It is maintenance predictive. You can work with a mobile app. It can run its own hydraulic models. It can help prioritize investments. It can be linked to any data source such as ERP, CRM, IPANET, GIS, stormwater management model, WMS. It is license free, and it can be used by unlimited users. It allows the issue management, and it is scalable. Moving on, let me tell you about the numbers of the Giswater software. It is used in more than 4 countries. More than 8 million people are served with it, and around more than 25 utilities are working with it. We want to clarify that we don't have a clear control on the number of downloads, as it is continually increasing. At the moment, those are the water utilities that we know of. We believe that several consulting firms and freelance engineers use the tool for their own projects. And of course, in terms of code, the source code factory is on GitHub, which has 2 main repositories, such as the QGIS plugin based on Python, while the Postgres database based on SQL and the PL SQL are both for the current 3.5 master branch, which has more than 14,000 commits, more than 40 years of effort according to the Kokomo model, and more than 30 contributors. These numbers are according to the website openhub.net, which we encourage you to consult in case you have any interest. Well, in case you don't know, Giswater has a powerful system to manage and trace any user working with it. In addition to having control of everything that is done at all time, users need to be logged with one of these roles detailed now, such as the basic, the OEM, the edit, the EPA, the master, and the admin. Later, Xavier will tell you a bit about each of them, hopefully. Finally, we want to tell you about the website that we have, which you can have the empty templates and example templates for the database schema, and also you have the user's manual in the website. In there, you can learn how to download and install Giswater. But also, you can check on the GitHub Giswater wiki how you can learn a project from scratch. Talking about the website, there's a lot of information on it. You can browse such as tutorials, how to provide code, and many more. Also, in case you have any technical doubts about Giswater, you can send a message to the forum. Many times we receive messages, and due to our workload, we may take some time to reply, so please be patient. We want to stress that this is an open source project, which is maintained thanks to the efforts of small companies, small water utilities, sorry. Therefore, it will only be sustainable through the different types of support we receive. So we invite you to download, try it, and share it with all your contacts. Like a bit of like a bit like a bit as Lindsay did. And of course, we will be glad to receive your feedback. Uh, talking a talking a bit about the goals for the future, we want to expand the project out of the borders of Spain. We already support the QJS project financially with 3,000 euros per year, but we want to increase our collaboration. And in terms of code, we want to upgrade the PostgreSQL version compatibility since the version 14 was released last week. We want to develop the 1D, 2D drainage coupled model, integrating stormwater management model plus IBER. And we want to enhance the API to integrate web mapping. And in case you want to follow us, we encourage you to do it through our social media, such as LinkedIn, Twitter, Facebook, and YouTube. We will be looking forward to your likes and your comments and any kind of feedback that can grow the project. And with this slide, I would like to thank you your attention. And in case you want to have more information about Giswater, please visit our website and feel free to share any suggestions. And sorry for the technical problem that I had in the beginning. It uh, kind of upset the whole webinar. But I will leave you now with Vicente Medina, which will give us a technical approach on the Giswater. Thank you so much.
Thank you very much, Claudia, for your nice presentation and for your technical problems as well. Okay, don't worry. And okay, I will share my screen. Okay, as Claudia was doing. And first of all, I'm Vicente Medina. I'm professor in the UPC, that is the Technical University of Catalonia. I've been for 15 or 16 years in the civil engineering school, and now I'm in the mechanical engineering school. I was in the hydraulics department, in fact, in the school. And my role here in this presentation of Giswater is just to help to introduce the technology that is in the background of Giswater. Okay, Giswater is a really technical product, and to help you to have a soft landing, okay, in the technologies on the background of the product, I will explain you some parts of this product, and I will explain you like a short history, the way I was introduced in the product, and I think is a good way to introduce you as well to these technologies. Okay, so I will share my screen. In the last months, instead of sharing PowerPoints, I used to share my tablet to do some drawings, okay, like a blackboard during the lectures. Okay, so I prefer this, and this way I can draw and explain you things. Okay, so the point is that it started, I think it was probably 10 years ago, Xavi, that you visited me first time?
Maybe
around 10.
9-10 years ago, yes.
9-10 years ago, I was in my office in the hydraulics department in the UPC, in the school, and Xavi and Sangi, I think the other partner of PGO, they came to our office. They were a small engineering firm, and they came with some ideas that were really amazing, and at that time, they really impact me. The point is that they were doing some engineering. They were mainly doing some master plans, water management or water supply system master plans and drainage system master plans. And they realized that there were two amazing tools, both open source, and I suppose that you know them, no? The SWIM model, that is an amazing model developed by the Environmental Protection Agency, no? SWIM model. And the other one was the EPANET model, another amazing model for water supply networks. No? Those models exist. Those both have an amazing computational engine. Really, the computational engine included in these models is really powerful, fast and powerful. But there's one weakness in these models, one handicap that was related with the user interface. So they realized that, okay, the tool is extremely powerful, but the way that I introduce the information to analyze my drainage network, to analyze my water supply system, it's really difficult. It takes a long time. The user interface is not so helpful. So they were interested in changing the graphical interface, or changing the way you introduce the information and you create the models, etc., etc. And their proposal, that was for me shocking at that time, is that they were thinking, in fact they were right, that most of the information you have for your networks, water networks, I don't care about drainage or water supply, is the same. Most of the information could be stored in a database system. So they were thinking, okay, mainly our networks, no, they are a kind of arcs, no, with information about the pipes. So I could have a nice table where I have all the data from my pipeline. Okay, then I have some that could be the pumps, or could be the valves, or could be the manholes. I don't care, but I have another kind of tables where I introduce the information of my nodes. Let's say that we can start talking about pumps. Okay, we have here our pumps, then here we have our valves. Okay, and again, it could be a nice table where I have all the data, all my columns about the diameters, about the power, the electrical power, etc., the cost, no, the provider, the supplier, everything, no? And their idea is, okay, I could have all my infrastructure information collected in different tables, and I can group these tables in something that we call a database, okay, a database. And at that point, I think that year before or after, I don't remember, I have finished my bachelor in computer science. And so when they talk about database, I knew perfectly exactly what were they talking about. And I was thinking about that point, and I said, okay, they are completely right. It's the perfect system to store the information about a network, water supply, or drainage system. It's in a database. So after having this conversation with Xavi and Sangi, my conclusion is that, well, we want to be involved in this project. Okay, the project was started in their company. They came to university to ask for help. Okay, we want some help to develop some parts of the code, and their technical proposal was really amazing. And the point is that their economical offer was nice because it was €0. No, we will not pay you for this task because this is an open source project. Okay, so finally it was something really, really, really amazing. But what did really capture us to decide we want to be involved was their technological proposal. Okay, so finally everything is rolling around a database. Okay, a database. This is database. They said, okay, what about how to deal with the geometry? No, geometry is all around in the networks. What could you do with the geometries? Could the geometry be stored in database? And the conclusion is that it could be stored because at that time, the geospatial databases were developed where you have a nice column, your last column, where you can store the geometry information close to the other attributes of the network. So at that time, the technology exists, and they were taking advantage of these spatial databases that could collect attributes and geometries. And they said, okay, then I need a tool to edit the geometry because it's clear that the attributes of the information could be edited here in my database. No, databases obviously edit the contained data. But in order to edit the geometry, I would like to use a GIS system. Okay, so I will edit the geometries using a classical, standard, and typical GIS for the users. It will be really easy for the users to edit the contents of the database. Okay, so when I move a point here, it will change this last column where I have with the geometries in my database. So the first proposal is, okay, we will use a database. The second, we will edit the information using a GIS system. And the last step at that time, that we will exchange information with our hydraulic models. So my database will export the models to the SWIM and to the EPANET, SWIM and EPANET. This was the proposal coming from VGO, from the enterprise, and obviously it shocked us in the university. In fact, I was sad thinking, how is it possible that all this technology has been developed in the private sector and we are not aware of this technology, and we were still constructing the input files for these models by hand. Okay, not by hand, but using a kind of technologies that directly write the input files. So it was a really better approach, the one proposed by VGO. That's why we decided, okay, let's go. We want to be involved in this project. Okay, and there were some interesting, there were crucial points. For example, it's a database support concurrency. We can have, I think that my record is having 25 students at the same time editing the same network. Okay, every student with its own GIS system in its own computer, and all of them working with the same data at the same time. If you work in engineering, you know that finally our work is mainly sequential, not parallel. You design the network, then it comes the hydrologist, then it comes the modeler, then the hydraulic, etc., etc. Finally, we are doing sequential work with Giswater and the product proposed by VGO. We can work in parallel, fully in parallel. And as soon as one student clicks the save button, all the other students immediately get the information from the data that the student has introduced. So something really, really, really amazing and really advanced for that time. Okay, and there were, for example, the constraints. Constraints said, okay, you cannot define an arc, you cannot define a pipe if there's not one node at the beginning and one node at the end. So databases include in native form something that we call the constraints. Constraints fix some limits of what can you do in the database. So if you create this data structure based in tables and you create the constraints, you have an extremely reliable system. You cannot broke your network, okay? Because the constraints doesn't leave you. You cannot delete a manhole that is involved in a pipeline, okay? So constraints were a second crucial point. And the third one was the topology. Topology means that, okay, my lines are connecting to nodes, okay? So finally, if I move this node, all the pipes going to this node will move. Okay, so there were some clear advantages of this approach of the database in front of the typical approaches we were using directly through exporting from GIS or manually creating the input files. Okay, so this was the technology that finally we decided, okay, let's go with them. After perhaps 3-4 years of development, let's say the version 1, we realized that our main customer, or the main user of this system, were not the engineering firms. They were the water utilities, and water utilities companies introduced two new elements in the system. The first idea for water utility companies, all the information should be based in catalogs. Okay, I have my catalog of pipes. Okay, my catalog of pipes. I have my catalog of nodes, and I have a lot of catalogs because in a company you always your material, the stuff you have in your network is always fitting in a pattern that is a catalog that the typical products that we buy. And secondly, in a company, there exist the roles that Claudia has introduced in one slide, telling you, okay, this is the admin, I don't know, this is the operation and management, etc. In a company, the roles exist. So the idea was, okay, let's introduce all the roles in the system of GIS Water. And there was something nice, that databases fully accept roles. So introducing roles in the system, introducing permissions, it's something that it's native in the databases. You can fully develop a role system based in database. Okay, so it means that it was a natural extra feature we add to the system. Okay, so at this point, the point where we are now at version 3.4, I think that we have a system that initially was fully adapted to engineering firms, so able to model with a lot of extra features, and we have a system adapted to water utilities, so including a lot of features that are mainly focused in water utility companies. No, so that's why things that could be a challenge for other products, okay, other network management products, like, okay, let's try to export your network to a water model. Okay, this could be a challenge, but in this system it's not a challenge because it was the first feature of the system. Okay, so now it's really easy to export really complex networks, water supply networks or drainage networks, to our hydraulic model in order to compute them. Okay, so I think, Xavi, perhaps it was enough as a soft landing in the technology. I don't know, what do you think?
It's enough. Nice. Very interesting. Very interesting. Always is a nice pleasure for me to listen to you. It always is a big difficult to me to talk after you, Vicente.
I'm sorry, Xavi, I'm sorry. But okay, Xavi and Sangi, I don't know if Sangi is here. They were the founders of this idea. So again, I always tell them, congratulations. It has been an amazing project, and it has been a pleasure to being involved and work with you.
Thank you so much. Okay, as I said, after your speech, Vicente, thank you so much. It's time for me to start my presentation. I will share my screen first of all. Okay. Okay. I am Xavier Torret, Technical Manager of Giswater Association and Partner Director of Vigeo. As Vicente said, the project was growing and water utilities were involved. This software take advantage from another softwares in terms of to have a PANET model ready to work or a stormwater management model ready to work, but it represents a huge problem for that users who they start to work with version 1, because for now there are lots of tables, lots of rules, lots of catalogs, no? Because this is not an hydraulic tool. This is a management tool with a native hydraulic capabilities, but it's a management tool. No? There was something like 3, 4, 5 years where there were difficulties to join both things, the management tool and the hydraulic tool. Fortunately, now tool is really well stabilized, and now in this moment to share this project, not only for a hydraulic model, also incorporating this management tool. No? And my presentation will be really a practical presentation. Okay, I will show you how to install the Giswater plugin, how to create DB schemes and QGIS project templates, and how to use the basic tools to try to understand the whole environment of things and capabilities that there are besides this database. No? And to do this, first thing that I will do will be to use this QGIS. Here you can see my really new QGIS. And first thing that I will do is to install plugin using the plugins dialog. First of all, I need to configure the repository of Giswater plugin. To do this, I will go to Giswater website, and here on downloads, you can find that latest version 3.5 and 15, it has an URL, the plugin URL. This is the URL you need to copy to go to the plugins repositories to add a new one, putting this and putting some name, something like Giswater Giswater repository. That's all. The Giswater repository is connected to work with. And the second thing, it's moment to download the plugin. Looking for Giswater, you can see that it's something like not enabled and you need to click install. You need to wait in order to download the plugin, only 10 seconds, 15 seconds, and that's all. Plugin is, let's finish, plugin is successfully installed. Okay, next thing to do is to connect our QGIS to some database, okay? To do this, we can use the Data Source Manager dialog of QGIS, which has lots of connections to WMS services, WMFS, raster, CSV, vector, amazing tool of QGIS to work with some of data. And in this case, we need to create the connection to our PostgreSQL database. Obviously, we need to have installed before. Okay, you need to install your PostgreSQL database. You need to install in your computer. You need to install on cloud. In fact, is a database. In this case, I have installed one database in my computer. The only thing that I will do is to connect it. I will connect it with the name of webinar. The name of connection will be webinar. The host is localhost because I will use for this demo my own repository. I will use the port 5435. It's not moment to explain this. No, a database technology like PostgreSQL uses the Internet Protocol addresses and uses the port issue to entry. You need to put the name of one existing database into that system. In this case, the database webinar exists. And last thing, to connect, you have the URL, you have the port, you have the name of the database. You need to log in, obviously using your log credentials. In this case, username and the password. Testing the connection, and connection to webinar was successful. It means that I have my QGIS ready to work with PostgreSQL database. Okay, perfect. Because if I have my QGIS ready to work with and I have my Giswater plugin installed, here I can have a button which shows the admin button of Giswater project. The admin button, using the connections you have enabled on your QGIS software, in this case, only one, ready to work with a project type, water supply project types or urban drainage project types, and ready to start to create my first database project scheme. Okay, project type, I will create a WVS project type. I will use the locale of English, USA. I will put some name, something like WVS sample. This description will be something like webinar project. And as I am working with example data, it's forced this example data to work with this system coordinates, because this is the official system coordinates from Barcelona, and this sample data with not real data is also from Barcelona. In this case, if you don't check this, software will force to put this if you are trying to work with example data. It's different if you use your ENP EPANET file or your EMP stormwater management file, or it's different to work with empty data, okay? But in this case, on this webinar, and I recommend you the same, it's very interesting to work with example data because we will have a full environment of catalogs and pipes and different kinds of capabilities ready to work with, okay? Three possibilities: empty data, example data, or import your ENP data. In this case example, forcing this system, okay? This process will take a little bit time. It depends of the performance of your computer, but let me explain you that at that moment, hundreds and hundreds of relations have been created into database. Tables, views, functions, trigger functions, sequences, and stuff. let me say that this, as Vicente explained you in his presentation, the whole system is into database. And as a result, there are more than 100 of sophisticated algorithms. There are lots of tables, and this takes a little bit time to create your project. I think it's not close to end, but okay, you need to be patient here. 1 minute, 2 minutes, and project with data will be ready to work.
Xavi, in fact, I forgot to tell that initially that everything was inside the database. We were not just working with Quantum GIS. At that time, we were able to connect and edit with different GIS systems. No, but
yes, because the algorithms, the intelligence, it was located into database, and there were no buttons on GIS to do nothing. No, only using the native tools of GBSIC, QGIS, including that Canadian GIS. I don't remember the name that we checked it and it worked fine.
The UDIC, I think.
UDIC. Okay. After that, when water utilities they were interested on the project, they start to request buttons. And as a result, the QGIS project has now lots of buttons. But these buttons are only buttons. They don't have intelligence. They don't have any algorithms. They don't have only logics to control workflows and buttons. And okay, the database data have been created. Let's check it. We have clicked this first button. Now I will click the second button that it is a create QGIS project file. With this button, we will create all the QGIS layers and tables related to that information into database. Okay, as project works with roles, it is possible to create different kinds of projects from basic to admin. Obviously, admin with full of layers, basic only basic information to work with role basic. I will create the admin project, okay, with the full layers. And here I need to put some name. I will put webinar 1 also. Webinar. And this is the folder to store it. Okay, that's all. I will export my password in order to make easy this demo. Okay, a credential will be stored. Okay, do you want to open GIS project? Yes, I want. Okay, GIS project is created in now and now needs loaded into QGIS. Maybe 200 of layers or something like this, and the information it appears here in our canvas. Let me explain a little bit more about this. First of all, I will try to add some kind of WMS service. I will go to the Institute Geographic Cartographic WMS. Okay, in order to connect some kind, because this is a new QGIS, and I don't have nothing. It doesn't matter. I will use the ECGC information. Okay, I will connect. It's perfect. I will use the orthophoto and I will apply. This is the orthophoto of this zone. Let time to refresh. I will put some kind of transparency. And before I start, let me present you Barcelona City and the Camp Nou, the Stadium of Football Club Barcelona, which is close to this area. Okay, this is Barcelona City. Okay, and the Camp Nou, which is Barcelona. I think it's not good moment to talk about football for Barcelona supporters because we are not in our best moment. But let me show you the Football Club Barcelona Stadium, which is close to this. And now I am here it is. Okay, this is the Football Club Barcelona Stadium, the Camp Nou. Okay, which Barcelona plays football, and let's say 10 kilometers from that, in the southwest direction, we have this sample data. It's not real data. It's full fictitious, fake, okay? And this sample data it's really interesting to show demos and also to start to work with, because it has lots of capabilities. Okay, and after my presentation of Come Now, I will present you the QGIS project and the QGIS plugin toolbar of Giswater. Here on the QGIS project, you can check hundreds of layers organized using roles, okay? Using roles. Because of that, as I decide to create a QGIS project of admin role, I have OM, inventory, edit, APA, master plan, and min and stuff, okay? And let me present you the huge plugin of QGIS with plus than 30 buttons, no? Which also is organized using roles. Here is the buttons used for the basic role. Here we have the buttons for the OM, here the edition, here the APA, here the master plan, and here utilities button. Okay, and let me start you presenting things. The info button. Okay, if you are looking for some kind of information, you can click here, and without change any layer in your table of contents, you can click on the map, and the project and the software responds with the feature identified. In this case, a junction with a rich form, which can be customized as you want. In this case, a node. If I click here, it's showing a pipe. If I click here, it's showing an info. Obviously, a double disjoint. Obviously, you can edit and change and to modify your information. Okay, this is the info button. Another interesting button is the filters. Okay, Giswater works with several filters. In this case, and the most important one is the exploitation, as this is a tool used by water supply companies that sometimes they need to manage more than one exploitation, let's say 10 exploitations, let's say 100 exploitations. In fact, in Brazil, there is a water supply company which uses Giswater with plus than 200 exploitations. And for this, it's mandatory to has this kind of filter in order to show, okay, first exploitation, second exploitation, and in this case, as this is a simple demo, one and the other one are really close. No? I can activate both of one. This is the exploitations filter. Also, Giswater works with three kinds of states: the operative state, which it means that that pipe exists; the obsolete state, which it means that that pipe have been existed but have been removed. But it's interesting for water utility to keep the whole information in order to use it as aggregated value to make AI or something like this with information that really a pipe does not exist, but the information of that pipe, it's interesting also in spite of have been removed. And not only obsolete, also planned network in order to plan your future network without interference in terms of this pipe does not exist, but need to be planned. Okay, these three states, it enables to work with this. And in this case, if I active the obsolete pipes, you can check that here there are some kind of obsolete pipes. And if I click the planned network, you can check that here in this case, some kind of planned network ready to show, only to really to know this replacement and new network ready to show. But in this case, we will work with obsolete. There are plus filters, but it's not moment to go further here. I will show you the third interesting tool for the basic users. That is a rich searcher, which it's possible, with them it's possible to look for some kind of asset inventory. Looking for, okay, this is a one inventory of some asset. Okay, typing the code, looking for some kind of address, some kind calle, let's say Galicia, and number, let's say 3. Sorry, let's say 3 here. In this case, there's no number 3. Okay, carré de Mario de Montserrat, and number 40. Okay, this is fine. Also, you can look for your customers. Also, you can look for your works catalog for your visits, let's say leakage, problems, maintenance operations and stuff. No, a nice searcher, not for hydraulic modelers, also for water management. Okay, this is the basic information. More interesting tools. No, I will follow a little bit my template. Okay, this is done. The basic tools are done. Edit tools. Okay. Another interesting issue of Giswater is the capability to use specific edit tools created to water utilities. Let's say I need to connect this Calle Galicia, no, with a new pipe, no, to this pipe. To do this, first of all, I will create here, I will put a T here. I will choose my T and I will activate my snapping. This is a new QGIS, snapping, database, advancing, snapping toolbar. Okay, I will activate my snapping using all layers and using vertex and segments. Okay, nice, perfect. And I will decide to put my T, let's say here. Okay, putting a T and selecting, in this case, only the catalog. In this case, I will put a T 110, 110, 110. I think this one. Okay, perfect. Software is ready to work as easy as possible because there are lots of value default data. Okay, it's ready to work easy. In this case, the only thing that I need to fill is only the catalog. Then I click accept, and this new pipe, this new T have been created, but not only have been created. Obviously, from now the pipes have been broken. Okay, because T is an element which breaks pipes. Maybe if I decide to put some kind of air valve, no, a score valve, maybe a score valve don't break pipes. You can decide this. For this case, obviously a T break pipe. I have the T, and the only thing I need to do now is to draw my pipe. I will draw my pipe connecting from here to here. Okay, perfect. And I will put a catalog, this pipe. Okay, this one. Perfect. Okay. There are specific tools developed to make as easy as possible the work of the editor role. Okay, and let me finish to put here some kind of valve. I will put some kind of shoot of valve here. I will put my shoot of valve here. Obviously, this shoot of valve is a valve which breaks also pipes, and in this case, this pipe will be broken again. Okay, that's all, perfect. These are specific tools. Oh, I'm sorry, because I don't like a shoot of valve. I like a hydrant. Sorry, I did a mistake. Okay, no problem. Let's go to select and change it. Hydrant now, and accepting. And in this case, now I have a hydrant. Okay, and there are more tools. Let's say, oh, I had a mistake again, because in this case, this hydrant is a mistake. This needs to be removed because there is no hydrant here. Okay, you can use this tool in order to fusion, no, to make a fusion of your arcs again. Okay, the arc is fusioned, the hydrant have disappeared, and you have the pipe as you had before. Okay, different tools you can explore it to connect links to network, to remove elements, to downgrade from state operative to state obsolete elements and stuff, to attach documents, to attach. That's all. I think it's moment to finish the show in terms of edit tool. What else?
Javier, sorry, can you please show how we can add a dramaturg? It's one of the questions that we have here on the chat.
Okay, to add a hydrometer, the first thing you need to do is to connect your hydrometers database on PostgreSQL, okay? When you have connected, the second thing you need to do is to use the double disjoints filter, something like this. You can make info here, okay? And as you can see, this form is a rich form with lots of information. In this case, you need to go to the hydrometer tab, and in this case, here on the hydrometer tab, you have information about your hydrometers. Okay, to attach a new one, a difference of documents. That to attach a new one, you can use this add button, or you can use this remove. To attach documents, you can use plus and delete. To attach events, some kind of leakage of maintenance of it, you can use the same new visit. To attach element, the same, plus and delete. But to attach hydrometers, this question is really very interesting because there is no button to attach hydrometer here. Because as this is a corporate tool, think it in a corporate environment, the key issue here is to relate automatically your customer relationship management software, your CRM, with Giswater using ODBC technologies or sort kind of integrations, no, on the back end of this, no, connecting automatically. This is thinking in this direction. This is not make sense to attach no hydrometer, nothing here, because the hydrometer information need to be linked or used from the customer relationship management software. No, it's not ready to attach using the user end, the end user dialogues. You need to connect using the backend. No, there are specific tables into database. Let's say hydrometer table, let's say hydrometer by data table, really to fill this data in order to connect this. But these tables need to be fulfilled using ODBC technologies or database technologies, not by the end user forms. Maybe if it's really interesting, it's possible to develop some kind of button here, but nobody requests before this because this tool is thinking to work with in a corporate environment, and nobody needs this.
In fact, Xavi, dealing with customers is more related to the CRM software, yes. No? We are, let's say, we are users of this data. We are not editors, yes, no?
Exactly. And you can connect using ODBC technology or stuff. You can connect using the backend of Giswater, but not to create exactly, no. A customer does not make sense to create a new customer here. Mm-hmm. Okay, let's continue. This is what else? What else? Add, update, or delete element networks. Okay, use the raster DM to calculate elevations. As PostGIS has an amazing management of vector data, but not only vector data, also raster data. This sample has raster data incorporated. As a result, this raster data, it enables us to, if we create a new element, let's say a new T, and we put this new T here, automatically an elevation is proposed. And this elevation is proposed because before to show this dialog, a spatial intersection into database is done, and as a result, this is the elevation of that point of the network. If you are looking to create a new T, let's say not here, but maybe here, and you repeat the operation, you will see that the proposed elevation is different because obviously here is higher in terms of elevation than the other one. No, this is an interesting tool because the editor, the user editor, only need to identify the catalog, and that's all. And as a result, no, it's very simple to have this GIS ready to model again, because without elevations, no model is possible. But if elevation is automatically proposed using this raster intersection into database, this is simple to work with. Okay, continuing. Dynamic info forms. Okay, this is the capability that the tool has to work with, to customize as you want here on each form. Let's say colors, let's say to hidden some kind of catalog label, because I don't use. My guys, they don't like because there is no information. We are looking to make forms smaller. I would like to put this another color. All is full configured. As we don't have any time, I will pass this to the next issue. But let me say you this: you can define the type of this name, the characteristics, including the color, including all is configurable. Okay, but I will pass this. Let's go to the next one, topological tools. Okay, this is on these last 7 years, working with that utilities and working with consulting firms, we have developed our own toolbox, no? With plus of 30 algorithms ready to work and to make easy things for user. Let's say works to check some kind of data. Let's say algorithms. Okay, let's check arcs shorter than a specific length. Okay, I would like to show if there is arcs shorter than 10 meters because because I need this. In this case, 60 arcs have been appeared. 10 meters is no problem, but maybe 1 meter, it starts to be a problem. In this case, there are no arcs shorter than 1 meter. Okay, my database is ready to work with EPANET because I don't have a shorter lines than that. And there are more tools, check duplicated arcs, check arcs with same start and node, check arcs with node start end, check duplicated connects, check node topology, etc., 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 etc. No? Lots of geoprocess to make easy the work for users. No, and the next thing, the next issue is to show you how you can work with master plan, how you can work using and managing alternatives, no? Using this planet state, no? Let me show you. Let me explain you, no? Imagine that you are in a water supply company and your boss says, okay, let's replace this pipe and let's replace this by a pipe with a major diameter and connecting, I don't know why. You can decide to work with your master plan. You can create a new master plan, let's say webinar. Okay. You can fulfill here priority, status. It's an ongoing master plan, executed, cancelled, no descriptions, lots of descriptions. In this case, only webbing, that's all. Okay. At that moment, my current piece sector, my current alternative is webinar. Any pipe, any node, which will be drawn by mine, if this pipe or node is planned, will automatically related to this master plan webinar. In fact, the sample project has plus than this webinar. No, it has 2 master plans ready to check and to understand how it works for you. But in this case, I have created a new one, and my current P sector is webinar. If I decide, no, I would like to make more pipes in the master plan too, okay, make this current P sector. Okay, I know I would like to, okay, no, in this case, I will use this webinar to attach new pipes. Okay, I have my webinar P sector, and in this case, the only thing I need to do is to create a new pipe. Let's say from here, an alternative to here. Okay, putting new diameter, something like PVC 200, and this is the key point. The state of this new pipe is not operative, it's planned. Okay, planned. That's all. the planet pipes has another color in order to differentiate it. And it's perfect because I have a new pipe created, but I have a problem because my boss requests me to what's happened with new pipe, but removing this existing pipe. And my work will be finished when I remove on this P sector, this pipe. In this P sector, not on the operative environment, because I know it's impossible to remove pipes if they exist. But what I can do is, okay, let's go to webinar. And in the tab relations, looking for an arc. And if you are looking in a specific P sector, if you are looking for an arc or for a connect or for a node existing, it automatically disappears on your P sector and it appears in your type of relations. Okay, in this P sector webinar, you have a new arc with state 1, which means operative in this P sector, and you have one arc with state 0, which it means this is not visible, this is not used in this P sector. And that's all. Now it's moment to make my simulation, my master plan issues in order to work with this, no? And feel free to check it, creating new sectors, creating new pipes, new valves, obviously using this plan. And the last thing to show you, because it's time to finish, is the hydraulic model, okay? Which is maybe the most interesting issue here, no? When I say that tool is ready to work with APANET or Swing, is because that's changes that we had here. Let's say creating new node with elevation. Let's say modifying this. Now it's moment to create my my APANET model. I have two options. The one option is to work with master plans. I can decide to create my APANET using the existing network, or maybe using the planet network. Well, I will create my first APANET using this planet network, using this webinar P sector created. That's all. I need to decide how many sectors. In this case, I will work with the whole sectors of this system. No, sector is the functional map zone, which explains from what source to what area is a sector. No, the header of the sector need to be a source, need to be a tank or reservoir. No, and this is the minimum aggregation of the elements to go to APANET. It makes no sense to try to export only a junction. It makes no sense to try to export 2 pipes and 3 junctions. What is the minimum aggregation of elements to export to APANET? Okay, that minimum aggregation of element which has some kind of source, let's say reservoir of tank. Okay, in this system, this minimum aggregation of one source related to one part of the network, it means 5 sectors. It means 5 sectors. Okay, and I will work with these 5 sectors, exporting this this first solution. And to export this is simple, because the only thing you need to do is to click here the Go to EPA button. In this case, you can select different options of exportation. It's not moment to explain, but you have the whole options of APANET. Let's say relative viscosity, quality mode, demand multiplier, units. The whole APANET options are down here in order to make easy to define your options here. Okay, and that's all. You can decide to create your first demo webinar, demo web number 1, exporting a ENP file, let's say demo web number 1, and that's all. Accepting. Okay, okay, ENP export done successfully. There is a huge check in order to guarantee the compatibility against data exported EPANET model. As a result, plus than 30 or 40 checks have been done. And the result is it's perfect because I don't have warnings and I don't have critical errors. It's perfect. No node orphans found, no node with, I don't know, no node without elevation, no node with tau, with no pipes with roughness. Everything has data fulfilled. As a result, I need to suppose that if I open my ARPANET and I open this file, demo web 1, it's ready to work, including this, okay, ready to work. And obviously, run was successful. I can export my second EPANET file, but in this case, using the filters and removing this webinar master plan and also working only with sector 1 distribution, only working with this, which this is only a distribution sector from this tank. I will repeat the process. I will create, no, in this case it's different, without pipe and without the rest of the data. Okay, perfect. I will click here again. I will click, I will put this label here and I will put this another file, demo web 2. Okay, perfect, accepting. Okay, a new file is created, no critical, no warnings, only infos. I can go to this file. This is the demo 2, it's here, open it. And in this case, as you can see, only this sector, this distribution sector without P sector have been exported. And in this case, run was successful, including on-the-fly transformation, because this object on the first exportation, it was a tank because it was, there were sources to provide water. But in this case, as this is the header object, this is not a tank, it's a reservoir. This is that kind of on-the-fly transformations that Giswater does in order to make it as easy as possible work for hydraulic modelers. No? I can open the first one, and you can see that for the first one, no, the environment is a little bit more sophisticated because this is a tank. Here you have valves, and here you have your reservoirs because this is the source, the impulsion environment to provide water to the water tank distribution element. And I think it's time to finish. It's too late. I'm so sorry because I have delayed, let's say, 15 minutes. Okay, for me, that's all. I really appreciate your feedback. Try to check it, try to work with, working with sample, it's very easy because it's really to work with. Try to understand the complex data model which has into database. And we really appreciate your feedback and also your support, your collaboration, because as I said, as Claudia said before, we are looking to expand this project out of the borders of Spain, not only US. This is our winner focused for US time and calendar, also for Europe. In fact, we are starting projects in France, in Portugal, also in Romania, and not only Europe and US, also the worldwide. No, and for us, it's a nice pleasure to contribute to make the world a little bit better using open source technologies. Do not make some kind of extra money issues that we don't like. And this is open source. This is not free. Let me say that behind you are looking, there are lots of medium and small water supply companies involved in not keeping for the project, keeping for the sustainability, and obviously they are very interested. They're really very pleased if they see that project is expanding out the borders of Spain, because it's the best way to guarantee the sustainability and also the growth of the project. And that's all. I don't know if there are some kind of comments on the chat, Claudia.
Well, we had some, but Vicente has answered. Thank you, Vicente, for answering,
okay.
and also for all of your comments. They are really relevant to to show the importance of Giswater. And I don't know if anyone has any more questions.
Let me say that project is really complex. Project is huge complex, as some of these attendees, like I see before that there were, I don't know, Adrian from US also, who has requested our support to try to work with, because it's not simple to work with. Okay, sample makes easy that things, no, in order to understand about start projects from scratch, as well as we document in our GitHub and wiki and docs, as well as we try to make better and we try to make easy on each release. This process is also, there are lots of things to be known. No? You need to know about database issues. You need to be a GIS expert. You need to be a GIS hydraulic modeler. You need to be lots of things. You need to know lots of things. And for this reason, the project is expanding also, providing different trainings. We are training on Costa Rica. We last week finished one training on Brazil. Maybe we will train also in South Africa next month. I don't know. Trainings are good ways to expand this project, but not only train, no? Also, in a corporate environment, it's difficult to keep this operative, and at that case, no, BGO provides support all over the world to keep this technology operative in your water supply company. If you are an engineer, feel free to make a download and enjoy it. But if you are, as an engineer, you are trying to upgrade your project, maybe you will have problems because it's not easy to keep this forward compatibility with ancient versions here. But for engineers, it's very perfect, because this release is really amazing for an engineer, for a civil, for a consulting firm to realize some kind of master plan. It's amazing. You don't need to do nothing, only download it, work it. But on a corporate environment, no, you need to keep and sustain this data for 10 years, 15 years. And on corporate environment, we recommend to look some kind of service to make this real, not giving the last versions of Giswater with any problems and with any things to, and only enjoying the software. I don't know if some doubt more.
No, Javi, no.
Lindsay, something to close?
I just appreciate it. Yeah, I just appreciate you guys showing the functionality of the software. And, you know, as far as solutions that are community driven, open source, more extensible than proprietary solutions, I think it's just cool to get the exposure for GIS water and just introduce people to what's possible. So thank you, Xavier and Claudia and Vincent.
Thank you, Lindsay, for your invitation to make this webinar on your land.
Thank you so much, Lindsay.
Okay, that's all.
Lindsay, when are you planning to come to Spain to visit us?
Oh, anytime. That's not a difficult one to happen.
Okay, guys, it has been a pleasure. Thank you, everybody.
Thank you, everybody, also.
Thank you so much. That was awesome.
Bye.
Thank you,
Bye.
everyone.
Thank you.
Bye-bye. See you.
Bye.